Welcome back. In the last video, we saved our best performing VIT model, which was a pre-trained VIT model that we adjusted the classifier head to work on our own problem. And we checked out its model size and we found that it's 327 megabytes, which may be a little bit big if we wanted to deploy it to a mobile application or a web browser, if we were building Food Vision Mini as a production application. And so in the last video, I said there's a challenge to compare it to the model that we trained in section 7, EfficientNet B2, which was 29 megabytes. Then if we look at the values that they got on the different data sets, and there's a little note here that yes, the EfficientNet B2 feature extractor from the last section was trained on 20% of the pizza, steak, and sushi data. So to compare apples to apples, we would have to retrain this on 20% of the pizza, steak, and sushi data. So that's an exercise or an extension that I've got down here in exercises. But if we compare this, is it worth it? That's the main question. If we were looking to get the best performance, the VIT feature extractor model is about over 11 times or about 11 times bigger than the EfficientNet B2 feature extractor. But the test accuracy performance is roughly the same in terms of the best results. So I'm taking the best one here, 9384, if we were to save that one. The only real difference is that the VIT feature extractor has a slightly lower test loss value. Now, this is something you're going to have to think about when you go to deploy your models, is the bigger model, remember, generally in deep learning, the bigger the better, but if you have compute restraints, is the bigger model worth trying to get it into production versus the smaller model? So this is only something that's going to come with practice, but it's just something to think about. We're going to cover more concepts about model deployment in the next section, which is not here yet, but it'll be PyTorch model deployment. But that's just something to check. So if you're getting good results with a model that's 11 times smaller than another model, potentially it may be more worth deploying this. So the example, Nutrify.app, this is an application I'm working on, is using very similar techniques to Food Vision Mini. And if we upload an image, if we go 04 Pizza Dad, which is the custom image we've been using, upload that. So this model runs in the browser. Now, there's no GPU powering this. So if we wanted to compute on this image and predicted food, pizza, and there's the macronutrients for the average pizza, it went pretty quickly. So something you'll have to think about is that will a model that size 327 megabytes take longer to compute and provide a good experience for someone using it versus a smaller model that gets roughly the same results but is almost instantaneous? Just something to think about for when you deploy your models and build machine learning powered applications. But with that being said, let's finish off this section and replicate what we've done here, but with our pre-trained VIT model. So we've done this a few times now. That is section 11, predicting on a custom image. So give that a shot. We've covered that in the previous section as well. But this time, instead of using the EfficientNet V2 or B2 model, use the pre-trained VIT feature extractor that we just trained. Give that a shot, and I'll see you in the next video.